Hello and welcome back to another video. In this problem, we're told that given that the limit as x approaches 2 of 5x minus 7 is equal to 3, illustrate definition 2 by finding values of delta that correspond with epsilon equals 0.1, 0.05, and 0.01. So what we have to do here is say, first of all, what is the definition 2 that they're talking about here? And it's saying that if we have the limit as x approaches a of f of x being equal to L, right? So here, that would be the limit as x approaches 2 of 5x minus 7 is equal to 3. Then, this is true if for every epsilon greater than 0, there is a delta greater than 0 such that 0 is less than x minus a, absolute value, is less than delta. If this is true, then f of x minus L is less than epsilon. So we'd be saying here, if 0 is less than, x here is just x, a is 2. If x minus 2 in absolute value is less than delta, then the absolute value of f of x, which is 5x minus 7, minus L, which is 3, is less than epsilon. Or 5x minus 10 is less than epsilon. So what we can see here is that for whatever epsilon we are dealing with, right, we can have that correspond to a particular delta. And so firstly, we are going to ignore the value at which the absolute value of x minus 2 equals 0. This would mean that x minus 2 equals 0 and x equals 2. Right? If we do that, then we can eliminate this part of the inequality. Why? Well, if we're saying that this absolute value is greater than 0, what does that actually mean? That really only means that it's not equal to 0. Since an absolute value is not negative, if it's greater than 0, the only thing we're excluding is 0 itself. So if we do with the caveat that x is not equal to 2, which we can ignore because we're taking the limit as x approaches 2, and we are therefore looking at the behavior as it gets closer to 2 and not actually at 2 itself, we can ignore this. Why? Because then we have x minus 2 is less than delta. If this is true, then 5x minus 10, which we can write as 5 times x minus 2 if we factor out a 5, is less than epsilon. If we are taking 5, we can take it outside of the absolute value. It's less than epsilon. We can do this because it's positive, right? So multiplying by 4 and then taking the absolute value, or taking the absolute value and then multiplying by 4, it doesn't really matter because changing this isn't going to make it negative again, so it's just positive no matter what. But we have 5 times the absolute value of x minus 2 is less than epsilon. Dividing by 5, the absolute value of x minus 2 is less than epsilon over 5. We also know that the absolute value of x minus 2 is less than delta. Therefore, we can say that delta is equal to epsilon over 5 for whatever epsilon we choose. Therefore, if epsilon equals 0.1, delta equals 0.1 divided by 5, which is 0.02. If epsilon equals 0.05, epsilon equals that over 5, which is 0.01, and if epsilon equals 0.01, delta equals that divided by 5, which is 0.002. So therefore, by finding the relationship between epsilon and delta, we were able to find the corresponding values of delta.